Good morning, everyone. Am I audible? Okay, I am audible, right?
Yes, ma'am.
Okay. Okay. So, uh, last class we have discussed about the secondary treatment for your biological filtration of sewage. So within that, we have learned that there are two types of systems for your filtration. That is your number one is your attached growth system, and the other one is your suspended growth system. Okay. So for under your attached growth system, your trickling filter is falling. It is under your attached growth system. So this trickling filters, so actually it is, you can say that this is also known as your conventional trickling filters, or you can say it as a normal rate, trickling filters. Okay. But nowadays, basically, high rate trickling filters are used. So this trickling filters, how actually they work, that these filters, they have, it is also known as your sprinkling filters, or also you can name it as your as percolating filters. Okay. So it these filters, it consists of some tanks. Okay. It consists of some tanks, and that tank, it consists, some coarser filter medias, and this coarser filter medias, and above these coarser filter media, so what is happening, the sewage, it is allowed to sprinkle in this filtering media. Okay. How the sewage is sprinkling, or it is trickling down this filtering media with the help of some spray nozzles, or you can also say it as a rotary distributors. So there are some spray nozzles, or there are some rotary distributors. Basically there are 4 rotary distributors are there, through which the sewage is falling, or it is sprinkling down over the filtering media. Okay. So this percolating sewage, the sewage that is percolated, it is collected at the bottom of the this tank, and there is a well designed under drainage system. Okay. So this is basically the simplest working of your trickling filter. So basically what is happening here is that whatever the organic matters that are present in the sewage, so the decomposition of these organic matters, this is brought about by some microorganisms. So these microorganisms, or these are actually these are present in the sewage itself, and they as a result of this trickling filter, so they get attached to this filtering media. So these microorganisms, they get attached to this filtering media, and this organic matter, that is from this sewage, it also gets absorbed from the biological film, which is it is formed by these microorganisms. So as it was discussed last class, like in your contact filters also, so a biological film is produced by these microorganisms. So this organic matters, it get attached to this biological film of this organic this formed by these microorganisms. Okay. So I just want to show you the one section of a trickling filter. So this is a trickling filter, you can see. So basically these are through here, the sewage, it is coming, the incoming of the sewage is through this wires, you can see through here. Okay. So these are, and this one you can see, this horizontal one, this is known as your rotary distribution arm. Okay. From here only the water, the sewage water, it is sprinkling to this filter media. So this is your filter media. Okay. This whole one, you can see with some circles there, holes there. So from there spray this sewage is coming, and this is the filtering media. So the sewage, it is entering to this filtering media. Okay, so this is the sectional view of your trickling filter. But I would like to show you one video related to this trickling filter, so that it is more understandable to you in a practical way. Okay, so let me just share one video. First, to see this video.
Now that the wastewater has been pumped to the trickling filters, the mechanical and physical process of primary treatment are concluded. The next step is biological treatment, which is known as the secondary treatment process. The wastewater that is pumped from the primary effluent wet well to the top of
So basically, I was telling you about this one. Okay, these arms you can see, these 4 arms. These are known as your rotary distributors. Okay, and these are the holes that you can see, and the sewage water, it is coming out from these rotary arms. And this is the filtering media. Okay, this has some pores here, so the water, it is going down. Okay, in a coarser media. So there is a coarser filtering media in at the down of this part. Okay, and the water, the sewage water, it is going down there. Okay,
of the 2 trickling filters is spread evenly across the surface of the filters through revolving pipes known as distribution arms. These arms have holes known as ports. The trickling filters are 86 feet in diameter and about 46 feet tall. You can see these structures as you drive along Route 1 between Cook's Corner and Main Street. The biological treatment process happens when microbes consume organic matter in wastewater and convert it to carbon dioxide, water, and energy for their own growth and reproduction. The microbes grow on a plastic cross-flow type media, which looks like a honeycomb. The media in each filter is 22 feet deep. The cross-flow design enables more biological treatment to be accomplished in a smaller space because of the increased surface area. The surface area in each filter is 3,830,000 square feet, the equivalent of 80 football fields. More area means more room for microbes to grow. The slimy growth on the trickling filter media is called a zooglial mass. It is where the microbes such as nematodes, stalked ciliates, and rotifers live and break down the organic chemical bonds in the waste. When the biological treatment in the trickling filters is complete, the microbes have eaten their fill. They are fat, dumb, and happy. The microbes will die from lack of oxygen. They fall off of the trickling filter media and exit the bottom of the filter as a solid called humus, also known as secondary sludge.
okay, another video is there.
Cities and towns
Trickling
have
filters
sewerage
are
systems
biological
in place to carry the
reactors within
wastewater from
wastewater
our
treatment
homes,
plants.
hotels, factories, and other establishments to a sewerage treatment plant.
Trickling filters are biological reactors within wastewater treatment plants, which are used to remove organic matter and/or ammonia from wastewater. Compared to the activated sludge process, the microorganisms are not suspended in the mixed liquor, but they are attached to a fixed bed surface. Nowadays, the fixed bed surface is usually provided by structured plastic fill media, but in the past, rock, gravel, and hardwood was also used. Wastewater from primary clarifiers is continuously trickled over the first layer of plastic fill media using a rotary distributor. While wastewater is traveling down to the bottom of the trickling filter, a cross-corrugated pattern within the plastic fill media ensures a good water-air mixing. Trickling filters are operating under aerobic conditions, but mostly without the use of forced ventilation or aeration. Instead, the tower shape of trickling filters causes that air is sucked inside the tower over slots at the trickling filter bottom. This effect is also called chimney effect and results from air buoyancy, which occurs due to a difference in indoor to outdoor air density resulting from temperature and moisture differences. For the design of trickling filters, three components are very important: the support structure, plastic fill media layers, and the rotary distributor. The support structure has to withstand high vertical loadings of up to 50 kilograms per cubic meter, 3 pounds per cubic feet of plastic fill media, plus up to 250 kilograms per cubic meter, 15 pounds per cubic foot for attached sludge and water inside the fill media packs. At the same time, the supporting structure must leave enough space for sludge collection and removal and to avoid blockage of plastic fill media channels. Therefore, the support structure typically consists of PVC stanchions, FRP grating and slope corrector plates to adjust for bottom slopes. The plastic fill media layers must provide enough surface area for attached growth of microorganisms, ensure a good water and air mixing, as well as withstand structural loadings. Typical removal rates for trickling filters are between 5 and 20 grams BOD per square meter plastic fill media surface area per day and 1 to 2 grams ammonia per square meter per day. Plastic fill media is a
Okay, so the design part is not needed. You have seen the video. So, sure. So now you have the idea like how the trickling filter it is working. Okay, so you have seen the rotary distributors and also the wires you have seen. Okay, so as a whole you have seen the trickling filter. So now coming to the okay. So now coming to the types of trickling filters. So how many kinds of trickling filters are there actually? So basically there are two types. Number one, as I already said, that one is your conventional trickling filters and the other one is your high rate trickling filters. So this conventional trickling filters, it is also you can say it is like standard or low rate trickling filters, and the other one is your high rate trickling filters. So this low rate trickling filters are nowadays it is not generally used. So nowadays these high rate filters or high rate trickling filters are generally used. Okay, so and this conventional trickling filters and these high rate trickling filters both are, they have the same constructional details, but they have only one difference in them, and that is, yeah, like in this high rate trickling filters, or the recirculation of sewage is allowed through this filters. Okay, by like you can pump a part of this filter effluent and to the primary sedimentation tank or primary settling tank, and you can repass the sewage in the filter. Okay, so that is the recirculation of sewage is happening in this high rate trickling filters. And also these high rate trickling filters, it actually makes it possible to like pass the sewage at very great loadings. And if there is great loadings, then what is happening, that is they are requiring very less space and very less filtering medias. Okay, so that will be less costly. So that one is your like you can say some kind of merits over your conventional trickling filters. So now coming to the merits and demerits of the trickling filter. So there are many advantages over your conventional and your high rate trickling filters. That does this, the advantages, if I say that the rate of this, trickling filters, or this rate of this filtering load is very high. Okay, and they require very less space and very less area, you can also say, and very small quantities of filter medias are required while doing their installations. And also the whatever effluent you are getting from these trickling filters, they are very stabilized, and they can, this trickling filters, they can remove about like 75% of this BOD and like 80% of the suspended solids. Okay, and this working of these trickling filters, these are very no, they do not require any skill supervisions. It's not required. This, the working is very simple. And these operation, it is also kind of, it is very flexible, and also they can like withstand the different concentrations of this sewages, and also different compositions of this sewage. Then also these trickling filters are self cleaning. It is self clean, and this the wear and tear of this trickling filters, these are also very less. And also the trickling filters, it operates more in a efficient way in this warm weathers, or in a very warm type of weather. And it also produces a very a BOD, that is a very effluent that has a very low BOD. Okay, so these are like somewhat of the merits of this trickling filters, and the disadvantages are also there. Like the in this disadvantages is like the cost will be very high. Okay, the cost of the trickling filters is very high. Then these filters, they cannot they directly take the raw sewage. Okay, because primary sedimentation, you have to do primary sedimentation before you take the sewage to these trickling filters. That is a disadvantage. Then also the head loss through these filters, it is also like automatic this dosing is required for this type of filters. Okay, then comes your like these filters, they also okay, they also have different troubles are also there. Okay, so one is their fly nuisance is there. So fly nuisance is like, well, in this filter there are some flies, okay, which develops in this filter particles itself, and this may cause some nuisance to these filters. Okay, and they should be removed. Okay, so how you remove this flies? So like you can do the flooding of these filters, okay, with sewage. So you can these flies can be, it can be removed by you just flood the filter medias with this sewage for about, you can say, 24 hours, or you also you can keep it for some more time also. So this, as a result of this flooding, what will happen is that this flooding, they will destroy the larvae. It is larvae. So the small flies, so these are called the eggs, you can say. So they will completely destroy these larvae, and also like they will interfere with the results of these operations also. So again, there are some different methods also for controlling this nuisance. Like you can use insecticides also. Insecticides, like you can use DDT, then you can use benzene hexachloride. So in the filter plant, you can use all these insecticides also. So in this way, you can control this fly nuisance. Then comes your other nuisance. So generally, in a trickling filter that has rotary distributors, they are not generally the problem of odor is not in the those trickling filters in which these rotary distributors are used. But when a fixed nozzle type of trickling filters are used, then what happens is that this hydrogen sulfide gas, and these hydrogen sulfide gas is a very odory gas. So these are released from this sprays and into the atmosphere. So what how can you remove this odory smell or this bad smell? You have to just chlorinate the sewage so that this hydrogen sulfide gas is not forming. Or you can neutralize to which is already it is formed, and you can just neutralize it by chlorinating the sewage. Okay, and comes your ponding trouble is there. So ponding trouble is means like the whatever in the filter media, the voids are there, you have seen. So these voids also, they gets clogged because in this sewage there is a heavy growth of this fungi and these algae. So these fungi and algae, they result in this ponding of the sewage. It is in this filter bed. So this trouble is given by this algae and this fungi, and they also can be controlled by, like, you have to just if you chlorinate the sewage, so that will kill these algae also. Okay, and also that will cause unloading of this material. So another methods are also there, like you can, if you add copper sulfate if to the sewage, then if you rest it for some time, then also this algae it gets removed. Okay, so that is your ponding trouble. Then coming to the design of this filter, trickling filters. Okay, so for the designing purpose, if some numericals is there, so we have to know some values for this designing of this trickling filters. So first, for the design of this, uh, when you design a trickling filter, so you first have to know the dia of this filter tank and also its depth. So you have to design the rotary distributors also and this under drainage system also. So when you design the filter size, you have to know. So first of all, you see here what loadings are coming to this filter. It can be given in two ways. Okay, so number one, you see, by the quantity of sewage applied per unit of surface area of the filter per day, so this is called hydraulic loading rate, and it is expressed in million liters per hectare per day. So in this filter media, okay, so what quantity of sewage you are applying to this surface area of this filter in per day, so that is known as your hydraulic loading rate, and it is expressed in your million liters per hectare per day. So you have to remember the this unit also, you have to remember. Then the value for this hydraulic loading is for, like, it is for conventional, if it is for conventional trickling filter, then this value of hydraulic loading, it is between 22 to 44 million liters. Normally it is taken as 28 million liters per hectare per day. Okay, and this hydraulic loading, it can also be increased to a more greater value. So it is, if you want to increase the, in case of these high rate trickling filters, you can increase the hydraulic loading, which is about like 110 to 330 million liters per hectare per day. So normally you can take the mid value, that is 220 you can take. Okay, so like now again this is hydraulic loading. Then another one is there, that is your organic loading rate. So organic loading rate is that how much of BOD per unit volume of this filtering media per day you are applying. So that is your organic loading rate, and this organic loading rate, it is expressed in kg of the BOD per hectare meter of the filtering media per day. Okay, so the value of this organic loading for these conventional filters, they may vary from 900 to 2200 kg of BOD per hectare per meter, and this organic loading for high rate trickling filters is 6000 to 18000 kg of your BOD5 per hectare meter in high rate trickling filters. Okay, so for conventional it is 900 to 2200, and for high rate it is your 6000 to 18000 kg of BOD, that is for your organic loading rate. Then coming to you can assume the organic loading rate. Okay, this is between your 900 to 2200. Okay, just wait. Okay. Okay, then here it is written, you can see that it knowing the volume and area of the cylindrical filter, we can easily find out its dia and depth. So if you know, obviously if you know the volume and area of the filter, so you can find out its diameter and its depth. So it may also be mentioned here that the filter dia and depth is designed for average value of sewage flow. So you have to remember this, that the filtering dia, okay, so the filter diameter and the depth, filter depth, it is designed only for your average value of your sewage flow. Okay, The rotary distributors, on the other hand, okay, the rotary distributors, then the under drainage system and other connected pipes, okay, they are designed for peak flow. Okay, this too you remember that the trickling filter diameter and depth, it is designed for average flow, and the rotary distributors and under drainage system, it is designed for peak flow. Okay, and the rotary distributors, it can be, you know, up to 60 meter in length. Okay, 60 meter in length, and it is desirable to keep the diameter of the filter tank to be 60 meter. Okay, to a maximum of 60 meters. So it can be below 60 meter also, but it is desirable to keep the at the maximum of 60 meter. Okay, and if the required filter diameter is more than 60 meter, then it is better to use more units of lesser dia. So if it is said that if it is coming, taking more than 60 meter, then you can use many units of this filtering medias of your somewhat lesser diameter. Okay, you can make lesser diameter of different more your filtering diameters. So now coming to the performance and of conventional filters and their efficiencies. So the effluent that you are getting from the conventional trickling filter plant, it is stabilized, as it is already said. So the BOD of this conventional trickling filter, it is reduced to about 80 to 90% of the original value. So whatever original BOD was there, so it will be reduced to 80 to 90% of this original value. And whatever BOD is left in the effluent, it is generally less than 20 parts per million or so. Okay, so the sludge obtained in the secondary clarifier is thick with moisture content of about 92%. So the sludge, which is gets accumulated or it is obtained in the secondary clarifier or secondary sedimentation tank, so it is very thick, and the moisture content, it is about 92%. So a conventional or standard grade filter plant is very useful to medium towns and industrial cities requiring full treatment of sewage. So these conventional and these standard grade trickling filters, these are useful for medium and industrial cities requiring very, all treatments that are required. So these are useful for those kind of cities. Okay, just give me 1 minute. Okay, so then the efficiency, it is given or it is expressed by a formula is there. So this is the formula. Okay, this is the formula. Eta is equal to 100 divided by 1 plus 0.0044 root over u. So where this eta is called the efficiency of the filter, and it's a secondary clarifier in terms of percentage. So whatever efficiency you will be getting, so that will be in percentage, and u here, u is the organic loading in kg per hectare meter per day applied to the filter. Okay. So this is all about the design part of your trickling filter. So let us okay, let us do one numerical related to this. So the question, it says that okay. The question, it says that the sewage is flowing at 4.5 million liters per day from a primary clarifier to a standard rate trickling filter. The 5-day BOD of the influent is 160 milligram per liter. The value of the adopted organic loading is to be 160 gram per meter cube per day, and the surface loading is 2000 liter per meter square per day. So determine the volume of the filter and its depth, and also calculate the efficiency of this filter unit. Okay, so first of all, this one. Okay, this 160. Okay, the organic loading is given to you. Okay, the value of the adopted organic loading is to be 160 gram per meter cube per day. So first, you have to, that it is for 5-day BOD. You have to find out, then the discharge is given to you that it is 4.5 million liters per day. So if you are going to find out what is the 5-day BOD that is present in the sewage, so you have to multiply whatever the sewage is flowing from this primary clarifier towards trickling filter. You have to multiply that one and with the organic loading value of this adopted organic loading value. Okay, so if you multiply this both, then you are getting the here it is 72000 gram per day. Okay, so they are getting the 5-day BOD by multiplying the discharge and this organic loading rate. So now, if you are going to find the surface your area, so you have to find the volume of the filtering media also. So the volume of this filtering media, the formula is your total BOD divided by organic loading. Okay, so if you divide total BOD, just now you got, okay, and organic loading value is also there. So it is already given. So you will get the volume of this filtering media as 4,500 meter cube. Okay, so that is one part of the answer you have got. Then you have to find out the depth you have to find out. So for finding the depth, you have to know first the surface area. So surface area formula is your total flow divided by hydraulic loading. Okay, so this total flow in the question, it is given to be 4.5 into 10 to the power 6 liters per day, and hydraulic loading value is also given to you, that is 2000 liter per meter square per day. So if you divide these both, you will get the surface area. So now you can easily find out the depth of this bed by just it is volume divided by surface area. So you are getting the depth of this bed. Now you can find out the efficiency. Efficiency formula is already given. That is your, we have just learned that eta is equal to 100 by 1 plus 0.044 root over u. So here, what is u? U is your organic loading. So organic loading, we have, it is given to be 160 gram per meter cube per day. So you have to convert it to kg, hectare per meter per day, just divided by 1000. Okay, so whatever value you are getting, you just put it in the formula and you will get your answer. Okay, so this is a very simple type of numerical. So now this is one table that is comprises of your okay, just let me give you the this attendance link. Please find it in the chat box, the attendance link. I hope everyone has got the link in the chat box. Just fill up the attendance, okay? Okay, so this is a table showing the differences of your conventional trickling filters and high rate trickling filters. So on the basis of some items like order characteristics, what is the depth of the filtering media for both these And then what is the size of the filter media, what is the land required, what is the cost of operation, what is the method of operation. So these are some kind of the characteristics that you have to go through this table about this conventional or standard rate filters or these high rate trickling filters. Okay, so this one is your self study. Please study this one by yourself. This is not very tough. It's just given the differences is given. Okay. Okay, so for today, this much only. Uh, okay, so till then, the meeting will end in 3 minutes. So till then, you please fill up this attendance that I have given the link. - 19 responses I have got. Okay, 20 responses. Those who have filled up the form, you can leave the meeting. Those who haven't filled up the form, please fill it up quickly so that I can end the meeting. 21 responses. Other students, have you filled it up? If you have filled it up, please leave the meeting.